Karanjetlilive.
Hi guys, welcome to my channel, and today in this video we are going to discuss event latencies in operating system, or we can say we are going to discuss event latencies in real time operating system. So guys, in this video we are going to discuss what is event latency, what are the different types of event latencies, and how we can minimize latencies. So guys, for the full video, all of you stay tuned. Now guys, coming to the definition of event latency. So what is event latency? It says the amount of time which elapses when an event occurs and when the event is served. Okay, now what do you mean by this? So something is going on and some event occurs. Okay, so then the operating system has to service that event. So how much time it takes, okay, when it gets that event and when it start processing that event, so the time gap between them is called as event latency. Okay, for example, something is going on and at time t0 an event occurs. Okay, so operating system gets a notification like then some event has happened which needs operating system attention. Okay, so then how much time is taken by the operating system to finish the current job or to jump from the current job to service that event? Okay, how much time it takes? Okay, for example, at time t0 event occurs and then at time t1 operating system starts servicing or that event or interrupt. So the time between the switch when the operating system gets to know that event has happened and when operating system starts servicing that event is called as event latency, this time. So at time t0 event E occurs, okay, and at time t1 real time operating system responds to that event. It responds to that event, and the time between t0 and t1 is called as event latency. Okay, so guys, by event means it can be any event or it can be interrupt. So when interrupt happens, what happens is operating system has to leave the present work and start servicing that interrupt. So it takes time till the operating system gets the notification and starts servicing. The time gap between that is called as event latency. Okay, so guys, now we are going to discuss the types of event latencies. And guys, these event latencies are of two types. One is interrupt latency and other one is dispatch latency. Now we are going to discuss them one by one. Now guys, the first thing which comes is interrupt latency. Now what is interrupt latency? It is the period of time from an arrival of an interrupt at the CPU and the start of the routine that services that interrupt. So what is interrupt latency? What time interrupt came, okay, and at what time the CPU started servicing it. So the time gap between that is called as interrupt latency. For example, in CPU some task T is running. Some task T is running. And at this point of time a interrupt came. At this point of time a interrupt came. So this much time is taken by the CPU to determine what type of interrupt it is. Number one, interrupt came. Number two, CPU took some time to determine what type of interrupt it is. So then CPU did the context switch. Number three. Now what is context switch? Context switch is when CPU jumps from one process to another. Okay, so this much time CPU did for the context switch, and here it started servicing the interrupt, and at here it started servicing the interrupt. Okay, so at this time interrupt came, and at this time interrupt got the service. So what do we call this thing? We call it as interrupt latency. So what is interrupt latency? Some task is running, so some interrupt comes, then CPU takes some time to determine what type of interrupt it is. Then CPU does the context switch. After the context switch, the CPU starts servicing the interrupt. So the time required to determine the interrupt plus the time taken by the context switch together is called as interrupt latency. So what time interrupt came and what time CPU started servicing it. So that time gap is called as interrupt latency. Now guys, the next type of latency which comes is called as dispatch latency. Okay. Now what is dispatch latency? In interrupt latency we take the total time. Okay. In dispatch latency we take the time taken by the dispatcher to stop one process and start another process. What do we call it? We call it as dispatch latency. Now formal definition: amount of time period required for a scheduling dispatcher to stop one process and start another. Okay, so this total is called as your interrupt latency, and in interrupt latency you have something called as dispatch latency. Now how it works? So suppose here is the event, and at this time our interrupt came. At this time our interrupt came. So from here to here, okay, CPU took time to determine the type of interrupt. Okay, so then now CPU, what it has to do is CPU has to process this type of interrupt. Okay, so to process it means CPU has to jump from the present task to the new task. Okay, so here it determines the type of interrupt, and here it determines the conflicts. Now what do you understand by conflicts? Conflict means some present process is running in the CPU. The CPU must save the state of that process. It must save the state of that process, and it must take all the resources back from that process. Okay, so then after saving its state and getting all the resources released from that process, it should dispatch the other process. So what is conflict? Conflict means saving the state of the present process and taking back all the resources, and if required assigning them it to the new process. So what is this? That thing is called as conflicts stage. Then after that, dispatch. Now what is dispatch? Selecting the new process which it has to execute in order to handle that interrupts. So we call it as dispatch. After this, it starts processing the execution. It starts the real-time process execution, means the process which sent an interrupt, it starts processing it. Okay, and this time gap to handle the conflicts and to dispatch the new real-time process is called as dispatch latency. Is called as dispatch latency. Okay, so what happens? A process is running, so CPU interrupt comes, CPU takes some time to determine what type of interrupt it is. So when after it determines the interrupt, it must switch from the present process to the real-time process or the process which has sent the interrupt. In order to do that, it must save the state of the present process and takes back all the resources which are issued to it. Okay, after that it should dispatch the new process. So the time taken to handle the conflicts and time taken by the dispatcher together is called as dispatch latency. After that, the real-time process, it starts the execution. So this latency is called as dispatch latency, and this full after the interrupt has come and the new process has started. What do we call it? We call it as interrupt latency. So guys, now in the next part we will study how we can minimize the latencies. So guys, actually here we cannot do anything. Here we cannot do anything. So in order to minimize this time, see, real-time operating system, in real-time operating system, everything is timing. Okay, so if latency is more, then obviously the CPU is going to take more time to generate the result, and the delay we cannot afford in real-time operating system. So there must be a way in order to minimize these latencies. Okay, here we cannot do much, here we cannot do much. So where we can do something is here. Okay, so we can try to resolve the conflicts quickly. Okay, and this time can be minimized. Okay, how do we do it? For that we have different protocols, okay, which we will study in the next part of this video. Now guys, we will discuss how we can minimize the latency. Okay, so guys, normally the latency can be minimized in the conflict phase. Okay, so you remember we studied dispatch latency. In dispatch latency there is a conflict phase. In conflict phase, what happens? The CPU takes back all the resources from a low priority process, okay, so that they can be assigned to a high priority process. Okay, so at conflict phase a lot of things are happening. Okay, and that is the phase which can increase or decrease the latency period, which can increase or decrease the latency period. Okay, so basically in conflict phase what happens? So we have to preempt the present process which has a low priority, and we have to replace it with the high priority process. Okay, preempt any process running in the kernel, okay, and release of low priority process of all the resources. So whatever the resources that low priority process has, so we have to take those resources so that they can be used by the high priority process. Okay, so what happens is we have a present process running, a high priority process comes, so we need to take the resources from the present process, we have to issue it to the high priority process, okay, so that the high priority process can finish the execution. Okay, now here this thing, it leads to another type of problem. We call it as priority inversion problem. Okay, so we call it as priority inversion problem. Now guys, what is priority inversion problem? Okay, now suppose we have three processes, L, M and H, and these are their priorities. L has the lowest priority, M has the medium priority, and H has the highest priority. Okay, so what happens in priority inversion problem? Okay, so normally what we say is, so according to priority, a high priority processes runs first and a low priority processes runs later. But what happens in priority inversion? In this scenario, sometimes what happens, a lower priority process can block a higher priority process. Okay, so which can delay a higher priority process, and in real-time operating system it can be really critical. Okay, now to explain it, suppose we have three processes, L, H and M. So L has the lowest priority, H has the highest priority, and M has the medium priority. It is less than H but more than L. So these are my three processes. Now suppose process L is running. Suppose process L is running, and at time t1 a high priority process comes, that is H. Now H needs the resources from L. At time t1 H comes and H needs resources from process L. Okay, until L can release the resources, as I told you, the taking resources and releasing resources, it takes time. When L is preparing to release the resource, another process M comes. Okay, now M comes. When M comes, L is releasing the resources, it is doing something, and H is waiting, So then at time 2, when the M comes, the priorities of M and L are compared. Why? Because M just came and L is still running to release the resources. Now here when the priority of M and L are compared, whose priority is more? Obviously M has the more priority. Okay, so but and at the same time M does not need the resources which are given to L. M does not need the resources which are given to L. Those are needed by H. Okay, while L is releasing the resources and H did not get it, M comes. Okay, the system will again compare the priorities. Okay, why? Because L is running and M has just arrived. So obviously M has a better priority than L. Okay, so here the system does not compare the priorities of M and H because H did not start running yet. Okay, L was running and M came. So obviously the CPU jumps from L to M and M starts running. Now why M starts running? Why didn't H run? H did not run because it needed the resources from L. So before L could release the resources and those can be issued to H, M came and M priority was higher than L and it did not need any resources, so it started executing. So after it finishes the executing at time T3, after it finished the executing. Now since this was executing, it took the CPU from L. So it again gives back CPU to L. Again L starts executing. Again L starts. Why L again starts executing? Because L did not finish releasing the resources. Since it does not finish releasing the resources, H could not start. And when M finished, again the process L started. Okay, so when after L finished, it released all the resources and then at time T4, the process H could start. The process H could start. Now guys, here you see process H has the highest priority and process L has the least priority. But which process was first to finish the execution? Process M. Process M, because first of all it did not need any resources, and secondly when L was about to release the resources, M came, and when their priorities was compared, M was with the higher priority than L, and since it did not have to wait for any resources, so it started executing. So after it finished the executing, it gave back the CPU because the context switch occurred and the state of L was saved. So obviously here again the context switch will occur. Again we will move from M to L. So after L finished, it released all the resources and finally H could get the resources and H could do the execution. Okay, now guys, here L was the least priority, H was the highest priority, but M was the medium priority. So ultimately how the processes finished execution? First of all the medium priority finished, then the low priority finished, and in the end process with the highest priority finished the execution. And guys, in real time system, priority is the main thing. Okay, if the high priority process cannot run, okay, and the low priority process keeps on running, so obviously it degrades the system performance, and in case of hard real time the outcomes can really be dangerous. So guys, this thing is called as priority inversion problem. This thing is called as priority inversion problem. So guys, I hope you understand it. Okay, now what is the solution for it? So one of the solution for priority inversion problem is called as priority inheritance protocol. Now what it is, we will discuss it in the next part. And now guys, the solution for priority inversion. One of the solution for priority inversion problem is priority inheritance protocol. There are many other solutions like disabling the interrupts and so on, but we will, in this part we will focus on priority inheritance protocol. Okay, so what is priority inheritance protocol? In priority inheritance protocol, we say if a low priority process is running and it has some resources allocated to it which are needed by some high priority process, then this low priority process can inherit the priority of high priority process, and it can continue with the execution of itself. Okay, so what do we call it? We call it as priority inheritance protocol. So when a low priority process inherits the priority from a high priority process and continue with the execution and continue to use the resources allocated to it. So what do we call it? We call it as priority inheritance protocol. Okay, now what happens here? So priority inheritance protocol processes assessing the resources needed by the higher priority process inherit the high priority until they finish the execution. And after they finish the execution, the priorities are reverted back. Now what happens? Here is time zero process L. It is executing and some resource R is allocated to it. Okay, and time T1 process H comes, which has a higher priority than L. It requests for resource R. So when it requests for resource R, the process L priority becomes equal to process H. It inherits the property of H and continue with its processing. Here L is equal to H. So whatever the priority is, it will inherit the priority of a high priority. So here L inherits H, and then at time T2 M comes, and time T2 M comes. Again the priority of L is H. The priority of L is H, so it continues. After it finishes, suppose it finishes at time T3. Again the priorities are reverted back. L is small, M is more, H is high. Okay, so again when this thing becomes, now again when you compare the priority, now what we are comparing? We are comparing M and H because they are inverted back. So which process will run again? H will run at time T3. So after H finishes the execution, then at time T2, M process will execute it. In priority inversion, what was the N was eating their priorities and it managed to execute first. Here M is executed in the last. Okay, L is executed in the first. Actually, ideally it should have been, but already the resources were allocated to it. So for the time being, we changed the priority of it. It became H and it executed at like H. After it finishes, again the priorities are reverted back to equal, and at time T3. So what processes we have now? L already finished. So we have M and H. Out of M and H, which has the high priority? H has the high priority, so H executes. Okay, it finishes at time T4 and then M can execute. So guys, what do we call it? We call it as priority inheritance protocol. So these protocols, they help us to minimize the latency phase. So guys, I hope you understand. So today we discussed what are latencies, what are the different types, what are the problems which caused by latencies, and how we can solve them. So guys, if you like my videos, please subscribe to my channel. I'll be uploading more and more videos related to IT, and all of you, thanks for watching and stay tuned.